Good morning, all. Can you hear me? Okay. Let me connect to Sridhar. Can I connect lab? So today we'll discuss about resource management and monitoring. In this module, we are going to cover assign shared values for CPU, memory, and disk resource. Describe how virtual machines compete for resource. Create a resource pool. Set resource pool attributes. Establish CPU and memory reservations and limits. Describe expandable reservations. So overall, we are going to learn assign share values for your CPU, memory, and disk resources, and shares, limit, and reservations. How we can do it? We'll describe in next slides. So in a typically VMware vSphere environment, many VMs run on simultaneously on a single ESXi host. For proper resource management, vSphere offers a set of mechanisms designed to guarantee access to resource when it is necessary. Okay, so to access the resource, we need to use three methodologies. Those are shares, limits, and reservations. These three methods you can able to apply on your powered on virtual machine. Okay. So in the diagram, we have taken a CPU or memory total capacity. Using that, we are limiting and reserving the resources, as well as yes, we are using the shares also. Okay. Shares. Let's discuss about shares. In shares, you can able to specify a value that is your total available capacity of your CPU or memory. It specifies the relative priority of a VM access to a given resource. If an ESXi host comes under contention and must decide which VM gets access to which resource. VMs with a higher shares assigned will have higher priority and therefore greater access to the ESXi host resource. Let me explain in the practically. Sridhar, is this vCenter IP address? So this module tells how to sizing or how to manage, how to monitor your ESXi host or virtual machines resources. Okay. And major components are CPU and memory. Okay. In T1 VM, what is the maximum CPUs we allocated? One CPU. And we allocated 1 GB here, 1 GB memory. Okay. So you want to share the CPU to from your ESXi host. So here we have already allocated one CPU. So virtual machine calculates your one CPU equal to 1 gigahertz, that is in virtual machine point of view, that is 1000 shares. So how do you calculate CPUs in a real-time environment? How do we calculate the CPUs? How do you measure CPU in physical environment? We'll monitor using the task manager. If you observe here, threads will be comes. Okay. And the calculation comes under your gigahertz, megahertz. Under that you will have threads. Like that in virtual environment also you will have the shares for each and every CPU. Okay. So shares will be by default, this feature will be there. Using this you can able to customize the shares, whatever shares you wanted to use. For example, here we have allocated one CPU, but as per my requirement I need only 500 megahertz only, but here I have allocated 1 gigahertz shares, so I can customize using this. Are you guys are able to follow me? So what is the advantage if I release example current scenario? You take the current scenario 1 gigahertz allocated for my T1 virtual machine, and I selected the low. My virtual machine requirement is only 500 megahertz. So I selected 500 shares. Now what happened to the other 500 megahertz or 500 shares, and what is the advantage I have here? Okay, good. Yes. So the rest of whatever free shares are there that can be used by other VM or your ESXi host based on your resource pools or your resource management policies. So that you can define under your virtual machines resources. Okay. So this is about shares. So whenever CPU comes, you can able to assign a value for your CPU resource. So using that you can able to share the required CPU cycles or CPU shares for your virtual machine. So is that clear, or you want me to repeat once again? One second. Give a minute. Sorry guys. Somebody call me. It's a missed call. It's a wrong call. When I told wrong number also, he again called me saying, provide your date of birth. I will prepare a certificate for you. Okay. Okay. So the diagram describes about available capacity for your CPU or memory. Here, I think we have this Sysmo some meter. We will call it as some meter. This is So resource we can calculate using that meter. I forgot that. So whatever it, some meter that is. Okay. So in that meter we will have total available capacity here. Okay. So in the using this total resource, we can able to reserve 25% of resource. We can able to do the reservation, and 90% we can able to limit from our total available capacity. In between whatever is there, we can able to use the shares. So are you guys are able to follow me? Once again, let me explain. Here we are using some meter to reserve or to limit our total available capacity of your CPU and memory. So using this total resource or available capacity, we are performing reservation, shares and limits. So out of total 100% of available capacity, we are reserving 25% of resource, and we are limiting 90% of resource out of total available capacity. In between we are using shares using this. Okay, this is about the diagram illustrates. Still have any queries? Let me explain about limit. Using the limit method, you can able to restrict the amount of a given resource that a VM can use it. Examples are maximum consumption of CPU cycles or host physical memory. This option is used to prevent a virtual machine from using more resource than specified. So if you take this example here itself, so in reservation you can able to, irrespective of your CPU or memory, you can able to reserve that. So maximum you are having here 1 GB memory only. So if you are trying to add more than that, it will not allow. Okay, if you observe that there is a brown color diamond symbol is there, so it means maximum you can able to reserve a memory for your virtual machine is 1 GB only. Okay, even CPU also maximum you can able to reserve 7700 megahertz. What was this physical system CPU capacity? It is 3.292 gigahertz. 3.29 gigahertz. It is a dual core. See that this processor is dual core. Let me check here. Yeah, core to Geo, this is one. So you have to calculate 3.2 into 264. 13 processors. I'm asking this virtual CPU socket will calculate based on your physical ESXi host CPU. So if you are allocated one CPU, maximum you can able to allocate 7700 megahertz, 770 megahertz. This value or this processor value comes from your base ESXi host machine. Are you guys are able to follow me? Okay. Let me explain about reservation also so that you can able to understand. So specify a specific amount of the resource for the virtual machine. This option is used to guarantee a minimum allocation of CPU and memory for a virtual machine. A virtual machine will be start only if its reservation can be guaranteed. So if reservation is not guaranteed, your virtual machine can able to power on. That is not a problem. But while powering on, it will validate your resource reservation. Okay, fine. Using the reservation as per this diagram, you can able to limit this. So shares you can able to use 225. Out of these 225 shares, if you wanted to reserve some of the resource and if you wanted to free the total capacity here in the CPU, if you compare with this available capacity diagram, you are having 7770 megahertz CPUs available. So I wanted to utilize only 1 gigahertz here. So out of 7000, if I use 1 gigahertz, it's almost only 20%, not 20%, even not, I think 7 or 8% I am utilizing. Around 13% I am utilizing it. So this is the way I am able to reserve resource for my CPU for T1 virtual machine. So okay, fine. Let me. It is good actually. So out of if I reserve like that, the rest of whatever is 6770 megahertz free space is there, that I can able to utilize for other virtual machines or ESXi host. If it is part of your ESXi cluster, if there are any resource pools are there, that will be consume this resource, free resource. Using the limit, you can able to maximum utilize the available or assigned CPU resource or memory resource for your virtual machine. Okay, by selecting unlimited option. Okay, if you haven't chosen unlimited option, you can able to utilize, you can able to customize that resource. Okay, so it means maximum whatever CPUs are assigned for your virtual machine, you can able to utilize it. If you remove that, you can able to customize it, that limit also. So assume I have customized it like this. My shares are 225, but I have 1000 shares. Total is, so I assigned only 250 shares, and my total CPUs are, total shares or total CPU value is 7700 megahertz here. So this I want to customize it. I want to reserve it out of total capacity. So I can reserve max 1000, or I can reserve max 7770. However, I wanted to reserve it dedicatedly out of 7770 resource. I wanted to dedicatedly assign specific amount of megahertz or specific amount of resource to this particular virtual machines. That is 1000 megahertz, that I can reserve it. Like that you can able to reserve 2000, 4000, 7000, 7770 till you can able to reserve it. Okay, as well as you can able to limit that particular resource also. Okay, but reservation and limit should not be conflict. Like if you allocated reservation 4000, and if you are limiting for 3000, that is not acceptable, and your virtual machine also won't accept, because reservation you are doing out of your total available capacity. So your total available capacity equal to your limit, nothing but. Are you guys are able to follow me? Okay, even same thing for your memory also. You can able to share or reserve or limit based on your infrastructure design. You have to be design these resource management methods. Okay, this will be help most of the VDA environments, as well as when you create resource pools in your production, development, or engineering environments. Wherever you wanted to use, you can use it properly. If you wanted to segregate resource, you have to use these methods in VMware virtual infrastructure environment. Any doubts? I'm moving to the next slide. How virtual machines compete for resource. How it will acquire. We can see that. So in the first diagram, it represents number of shares for each VM. We are having three VMs, VM A, B and C. Each VM having thousand shares. And change numbers of shares. The number of shares whatever is there, this is by default. When you create the virtual machine, by default this will be created. The shares will be created as per your resource. Okay. And the second one, change number of shares. This you can able to post deployment of your virtual machine. You have to customize it. If you observe that in VMB there is 3000 resources are there. 3000 shares are allocated. Okay. So this you can able to customize it. When power on virtual machine, if you wanted to power on the fourth machine with the same resource, you can able to power on it. So power of virtual machines, you can able to power of virtual machine with these resources. So are you guys observed any? Are you guys understand this first of all? What this slide represents? Overall, it says shares. Okay. So you can able to power on virtual machines with a specific resource or specific shares. But once you powered on whatever resources is there, for example, if you allocated by default 3000 shares for your three virtual machines, by segregating like this, you can able to power on virtual machines. Okay, and even you can able to power on with the maximum resource which is allocated or which is available for your total available capacity of your CPU resource. During virtual machine power on, it maximum consume whatever total available capacity allocated. Once it is powered on, that shares can be accessible whatever this virtual machine is needed. Out of 3000, this virtual machine need only 2200 megahertz. Then only the 200 megahertz will consume. The rest of 2800 shares can be accessed by these three virtual machines. Even in these three virtual machines also, maximum these three virtual machines we allocated thousand shares. Out of 1000, whatever is needed when powering on the virtual machines, only that will be consumed. So during power of your virtual machines, whatever resource is allocated, it will not, it won't use it. It means the resource is, it's only configuration perspective, it is allocated. It won't use any resource during power of your virtual machine state. Only power on virtual machine state only your CPUs can able to, your CPU shares can able to access CPU, memory or disk IOs, whatever it. Okay. From Whisper 5 onwards, your disk IOs also comes under your shares, limits and reservation part, because there is a option called IOPS monitoring, and IOPS performance feature is enabled from your Whisper 5.0 onwards. So using that, we can able to share, limit and reserve IOPS for your data stores, even local or shared data stores. Okay. So the overall resource you can able to share, you can able to change, and when while powering on, how your virtual machines can consume your actual shared shares, and during power of virtual machines, your shares can't be accessible. It is in configuration state, but it won't consume any resource. It means that is free. So when these three virtual machines are powered off, so I have 5,000 shares are free on my ESXi host. So I can utilize that. I can assign those for a new virtual machine or any other virtual machines. Are you guys are able to follow me? Any questions? Is it confusing? Any questions? So while designing, you should be know these concepts, and even these resources management can able to help you while troubleshooting your virtual machine performance issues. Okay, I'm moving to the next slide. So this is about resource pools. So a resource pool is a logical abstraction of hierarchical managed CPU and memory resource. So while seeing really about resource pools, apart resource pools, what are the information are you seeing on this picture or this slide? What are the components are you able to see it on this diagram? Apart resource pools. Are you guys are able to hear me? Okay. Data center cluster. Okay. What other components are there? Okay. So under host and clusters folder, I am having a new data center. Under new data center, we have CL-1 ESXi cluster. Under that, I have a ESXi host, single ESXi host. Under that, I have totally 5 VMs are there. Okay, fine. So even same thing is available on your lab also. You see that? That's why I told clearly leave about resource pools. Those are called resource pools. Okay. So those blue color circles or globes are called resource pools. We'll talk about. First, we need to identify what are the resources are there, what are the components are there in our virtual environment, where we can create the resource pools. So the slide illustrates root resource pool you can able to create under your ESXi cluster. And if you once you created the root resource pool under your ESXi cluster, you can able to create another or additional resource pool or child resource pool you can create on your ESXi host under whatever cluster is there. Under that ESXi host you can able to create a child resource pool. Okay, so child resource pool we will call it as a sibling resource pool. So in DNS, how you will have the root domain controller and child domain controller, like that you are having. So if you create the forest, and if you are that is called if you are implemented a domain controller, that is called first domain controller for your entire forest or for entire domain. Like that, here we will call it as a root resource pool, which is created under your ESXi cluster. Under resource pool, if you additionally added any resource pools on your ESXi nodes or ESXi hosts, those are called child resource pools or sibling resource pools. It's not single resource pool, it's multiple resource pools. When multiple child resource pools comes, then we will call it as child resource pools or sibling resource pools. Are you guys are able to follow me? Okay. So because why I'm creating this is it's similar concept for your resource pools. Your resource pools also say which one is the root domain in this diagram, which one is the in ms.com. Okay, so which are child domains? So only two are the child domain. Your Hyderabad hyd.ind.ms.com is child domain for your ind.ms.com. Okay, so here also you have the same concept. You will have a root resource pool that will be created on your ESXi cluster, and you will have multiple child or sibling resource pools under your ESXi host. You can able to create it. Let me explain about these particular resource pools. Hope you guys are able to understand where we can create the resource pool at present. Then we'll talk about parent resource pool and child resource pools. Okay. In vSphere, resource pool can be used to partition the CPU and memory resource of your ESXi host or your DRS clusters. Resource pools are created as objects on standalone hosts or your ESXi clusters to hierarchically partition available for your CPU and memory resources. Each resource pool can have shares, limits, and reservations. You can able to specify it. And resource pools offer a convenient way to separate resource along requirements and control the resource uses of multiple virtual machines at once. Okay. And also you can able to create multiple resources. Let's see first of all where we can create the resource pool. So in data center you can't create the resource pool, even you won't get that. Under ESXi cluster only you can able to get the resource pool option. Wherever resource pool is available, there you will get the resource pool option. Okay, I am creating a resource pool saying that root resource pool. So under this root resource pool, you can able to share, reserve or limit for your resource, that is CPU and memory. Okay. Overall here you can able to create the CPU and memory resources, shares, reservation and limit. Okay, I just created a root resource pool, and it is created here. If you go to the summary, it will show you what is the maximum configurations allocated. So reservation is the maximum and the limit also unlimited, shares also 4000. You can able to edit this using this tab. Okay, is that clear to everyone? Now my question is, where this root resource pool is created? Under cluster, in the sense which resource it is utilizing. Which resource that resource pool is utilizing. We have created a resource pool under a cluster, right? So it is using which resource? Yeah, exactly, cluster resource. Where we can see the cluster resource? And here you can able to see the cluster resource here. You have cluster resource has total CPU resource of 13 gigahertz and the total memory is 8 GB. Under this, we are on top of this resource, we are creating the resource pool. That is the reason if you see the resource pool here, you can able to see maximum shares as 16 GB. I think something is wrong here. It should display maximum 13 gigahertz. Is it DRS enabled cluster? Some reason it's not showing, but when you create the resource, it should display whatever total resource available on your cluster that will be present on your resource pool. Okay, here it should be 13 gigahertz. You can able to create, you can able to allocate on your resource pool, as well as this total 8 GB. You can able to create shares, reservation and limit. On these components only you can able to create shares, reservation and limit. Is that clear? Out of this, if you wanted to access resource from this particular node, that is not possible. Okay. So I will repeat once again. I have here in this lab, I have cluster A and individual node. If I create a resource pool, this resource pool can able to utilize the cluster resource only. It won't go and access your individual ESXi host resource. But you can able to create a resource pool for your individual ESXi host separately. Okay, fine. Now, under this resource pool, I can create another resource pool also. I can say child resource pool, and I can maximize or I can create. Okay. Now I can say root is my parent resource pool and the child is my child resource pool. Okay. Like that within the cluster I can create multiple resource pool. Apart root, rest of all are called as sibling resource pools. Is that clear to everyone? Okay. Any doubts on this slide? Okay, I'm moving to the next slide. So resource pool attributes, that is your CPU and memory management methods. Those are shares, reservations, and the limit. You can create a child resource pool of any VMware ESXi host resource pool or VMware vSphere DRS cluster. Under shares, you have various attributes. Those are low, normal, high, and custom. Under reservation, you can able to specify in megahertz or gigahertz for your CPU resource, and for your memory component, you can able to allocate. You can able to reserve MBs or GBs. Even limits also you can able to allocate megahertz, gigahertz for your CPU. For your memory MB or GB, you can able to allocate, or you can choose the unlimited option. Okay. So reservation types, you have two types, expandable selected and expandable deselected. Expandable selected chosen on virtual machines and subpools can draw from the pool's parent. In the sense, here you are having the parent resource pool. Whatever resource is there that need to be consumed your child resource pool. During that time, so your child resource pool wanted to utilize, it is exceeded and it want to access more resource. If you can choose the expandable selected resource, then you can able to use the parent resource pool resource. Whereas if you deselected this option, it won't utilize your parent resource. Your child resource pool won't utilize your parent resource pool. Any doubts? Okay, I'm moving to the next slide. Reasons to use resource pools. Use the resource pools can provide these benefits. Flexible hierarchical organization. Isolation between pools and sharing in pools. Access control and delegation. Separation of resource from hardware. Management of sets of virtual machines running on multi-tier services. Ability to prioritize virtual machine workloads. So let me ask you one quick question. So in Active Directory, why we need to delegate, or I can let me ask you this way: how many administrators are there in Active Directory? How many administrators are there in Active Directory? Or how many groups are there? Okay, enterprise, domain, okay. Yeah, there are multiple enterprise, domain, schema, global catalog, okay, some PDC, emulator, etc. etc. Like that, you have delegated various admins for your various resources to manage. Like that, in resource pools also, in the same manner, we have segregated or we have delegated resource using the resource methods, shares, reservations and limit. Using these methods, we are delegating resource via resource pool to your virtual machines. Okay, and that is also in proper flexible hierarchy manner. We are allocating resource to your virtual machines using your resource pool mechanism. Isolation between pools and sharing in pools in the sense, so you can create the multiple pools and you can utilize 100% of resource. So like here, root and the child resources we can create, resource pools we can create and we can allocate to these particular virtual machines, these resources. Okay. And even you can able to delegate or access control to your resource pools. For example, T1 can access only this particular root virtual machine resource, then I can do that. Okay, if you go to the virtual machines under root, you can able to see this particular T1 virtual machine can able to access only root resource pool resource, and even under whatever child resource pool is there, under your root resource pool you are having two components, that is child resource pool and one of the virtual machine is utilizing resource. This is your total resource of your root resource pool. Child and T1 objects can utilize the resource from these two components. Okay, like this I can able to give access control or I can delegate the permissions to allocation resource to these two objects. And now I can move this my virtual machine to child resource pool. So this T2 virtual machine, if you see here, under child resource pool, I have only one virtual machine, that is T2 virtual machine. So now T2 virtual machine can able to access only this particular child resource pool resource only. It won't consume the root resource pool. Are you guys are able to follow me? Any questions? So here that is what indicating access control and delegation for your resource pool so that we can utilize whatever available resource is there on your VMware virtual infrastructure environment under your ESXi host or under your DRS cluster resource, whatever is available resource that we can able to utilize it in a proper manner. And even we can separation of resource from your bare metal or ESXi hardware. Okay. Any doubts on this slide? Shall I move it to next slide? So in this slide, we have an example. So how we can use the resource pool. We have an IT company called X. It have two internal customers. One is financial department and second one is engineering. So each internal customer has both production and test or development virtual machines. So you must control the resource consumption of the test or dev virtual machines. So I guess this case study you guys can able to do it on a lab. Using the lab guide you can create it and you can do that. So here they given a company called X and they are having two different departments, that is finance and engineering department. Okay, and they are representing how much resource they required and how critical their virtual missions on your virtual environment. So this scenario you can implement using the lab guide, you can implement on lab, then you can able to easily understand. Okay, this is one of the case study. Even this you can able to explain in your interviews, saying that handled a resource management project on virtual environment. You can create as a project also this one. Okay, I properly designated or hierarchically I designed resource pools or resource management on my VMware virtual infrastructure. And then you can describe, compare with your company and infrastructure, and you can explain these points. Okay. Any questions on this slide? I'm moving to the next slide. So the same content, whatever slide is there in the above, that is segregated here. So resource pool example. This example shows where resource attributes are set on resource pool. So I am having the bare metal here, or I can say ESXi hardware here. Under that I created a department, or I have created a pool called engineering pool. I allocated 1000 CPUs and the reservation is one 1000 megahertz, maximum it can access 4000 megahertz, and the expandable reservation is yes. So it can able to, if it is exceeded engineering pool resources exceeded this limit 4000 megahertz, it can able to access from their parent resource pool. It can able to access the resource from your parent pool. Okay, that is the reason I enable the expandable reservation. Under this, I have created two VMs in production and engineering, test environment. And I allocated 1000 CPUs, maximum limit I gave 4000 megahertz. So it means this VM can able to access 1000 shares, and max it can able to access 4000 megahertz. I am sure I know this VM can max access only 1000 megahertz. Okay, but if it is beyond, it can able to access maximum 4000 megahertz. Like that in production VM also CPU shares I allocated 2000, and the reservation I created as 250 megahertz, limit I given as 4000 megahertz. In this scenario, in engineering prod VM scenario, so 250 megahertz will be reserved for this particular VM out of 4000 megahertz. This VM can able to maximum utilize only 3750 megahertz only. Okay, any questions? Simple thing, reservation in the sense, when you are going a hotel, you will already reserve your table. Even the same thing for your bus tickets also. While traveling, you will reserve your seat. It means you are already reserving a capacity for you, right? Like that, here also we have a available resource is there, that is CPU shares 1000, and the reservations are 1000 megahertz. Limit is 4000 megahertz for this particular engineering pool. And the expandable reservation is yes for this engineering pool. There is a parent pool also available on top of this. Okay, so it can able to expandable the reservation when this is reached maximum, or when this is exceeded, resources usage is exceeded. Is this part is clear? Now I have under engineering pool, I have two VMs. One is test VM, second one is prod VM. So test VM I allocated 1000 CPU shares. The reservation I haven't configured it, but the limit I given 4000 megahertz. It means from our engineering pool, whatever shares are there, that I can able to consume from here. As well as reservations I haven't configured for this VM, and the maximum limit is 4000 megahertz for this particular VM. So whenever this virtual machine starts powered on and it started accessing resource, maximum it can use 1000 resource, 1000 CPU shares from this particular engineering pool. At the same time, reservation I haven't configured anything. However, it can maximum usage reservation 1000 megahertz from this engineering pool. And the limit I have configured 4000 megahertz from this pool. Is that clear? Now coming to the prod VM, I allocated CPU shares as 2000, but my engineering pool CPU shares are 1000 only. It means whenever this VM reaches more than 1000 CPU shares is consuming, this engineering pool can send a request to parent resource pool saying that I need 1000 more shares for this particular VM. That is the reason we selected expandable reservation, and you can allocate, it means you can allocate whatever resource you required on your under your child pools based on availability on your parent and child resource pool resource. Any questions? Now coming to the reservation. So I have reserved 250 megahertz for my production VM, prod VM. So out of this engineering pool 1000 megahertz, mandatorily or mandately I need this particular VM need to be used 250 megahertz if it is consumed or it is not consuming. Dedicatedly it need to be used 250 megahertz. Okay. Any questions? And maximum limit is 4000 megahertz. So it can consume maximum 4000 megahertz. Okay. Whereas, is that clear? Any questions? Okay. Whereas expandable reservation option I haven't enabled it. However, I created like this. CPU shares I entered here 2000. It won't accept. It says your resource pool having only 1000 CPU shares are available. You cannot give more than expandable reservation for your production virtual machines. Yes, yes, Sridhar. So as we haven't done any reservation for our test VM, it can maximum utilize 750 megahertz. So it can enable, if it is down also you can't utilize it. And that is bounded to your prod virtual machine. So it means dedicatedly we are allocating to particular resource to your virtual machine using the reservation. Any questions? Shall I move to next slide? Okay. In this diagram, we are going to discuss about resource pools example CPU shares. So the same scenario we took here, we are having the finance and engineering pools. Here I have a ESXi host, that is SRV001. This is the root resource pool for your child resource pools, engineering and finance pools. Using these child pools, we are providing resource to your virtual machines. Okay. Any doubts in this slide? Any questions on this slide? So here you will have a challenge. For prod VM in engineering, you have 2000 CPU shares, but your engineering pool having CPU shares as 1000 only. So in this scenario, you have to enable option as expandable reservation. Then it can able to access the CPU shares from your root resource pool. Okay. Any questions on this slide? Finance also applies the same thing. Yeah. So we are just limiting here. See that we are just taking bunch of resource from our root resource pool and we are just limiting here. So that only this specific resource 1000 shares can able to access this particular VMs. Even if you crossed total availability also, total available resource also, it can able to max, it can able to access 1000 CPU shares. Whenever it's need more resource, then it goes to the expandable reservation option and it consumes from your root resource pool. So here we are creating a boundary for your virtual machine resource using the child resource pool. Okay. Otherwise, we can deploy simply, we can remove these pools and we can directly deploy the virtual machines on your ESXi host and it can access all the resource from your root directory. Okay. And whenever there is virtual machines need a resource, it can access from directly from your root resource, but it's not in a good manner if you deploy like that. The hardware and CPU, the hardware resource will be not utilized proper manner. Using the resource pools only we can able to manage your resource proper manner. Okay. And we can use 100% of your root resource if you use this hierarchy while using resource. So any questions? Shall I move to next slide? Okay. So resource pool example, CPU contention. So here we are taking only one component. So you are having ESXi host SRV01 whatever CPU is there, using that CPU, all VMs will be run on this particular CPU resource only. Here, if you take this in engineering pool, I used 33% of physical CPU for these two VMs, test and prod VMs. Whereas in finance pool, I used 67 physical CPU for this test and prod VMs under finance. The same thing here, they are elaborating here. Any doubts on this slide? But real time, this is an example to calculate your resource. Okay. In real time, you may have various resources are available. In the sense, you might have 7,000, 10,000 shares will be available on your ESXi host. Based on that, you have to calculate and you have to create the resource pools. Any questions on this slide? So out of 100%, here they are segregating the resource. Okay. So here in 22% actual usage of your total engineering pool. Total available capacity is 33. Out of that, I have 11% of physical CPU is free here. Okay, but my actual resource usage is, how many of you guys are aware of forecast? So in your environments, some new requirement come or every month users will be increased on your virtual infrastructures. So based on users count, we have to be increase the servers as well as hardware resource. Based on your users load, you have to be increased. So this will be calculated in every weekly or monthly. You will calculate that and you will submit a forecast to your management. In that forecast, you will say these many users are going to increase in the next few days or weeks or months. So this is the hardware is required to achieve that particular load. So like that, here also you are reserving space, reserving CPU shares is 33%. In that, actual consumption is 22% for your engineering pool. Out of that, 11% is your physical CPU resource is free. It's available to use it. That is also available for only engineering pool. In future, it is increases, usage is increases that can be utilized from this particular 11% resource. Even if you take here finance also, out of 67%, it is reserved for 45% is consuming, 23% is reserved for your future forecast. In future, if it is increases usage CPU resource, then it can use from your 22% unused or reserved resource pool. Is that clear? Any questions? Sridhar, Hari, any doubts? Sridhar. So shall I move to next slide? Okay. Okay. What is the actual share value of your CPU shares in the engineering pool? Okay. For test VM, how many CPU shares I allocated? So engineering prod VM I allocated 2000. So total is 3000. But however, you are able to see only 1000 CPU shares are here. But the actual requirement is 3000 CPU shares for your engineering pool. Right? So your question is, so I have only 1000 CPUs on my resource pool, but here I allocated 3000 CPU shares for my VMs. Is that your question? Yes. Okay. What is your query? Yes, we have expandable reservation. So then whenever it crosses the 1000 CPU shares, then it will consume from its own root resource pool from your bare metal or ESXi hypervisor. Whatever resource is available, that will be expand to your engineering pool, and that shares will be CPU shares will be consumed by your two VMs. That is also maximum 3000 CPU shares can able to access from your root or your bare metal ESXi hypervisor CPU shares. Okay, but here if you come to here explanation on this, out of 100% resource availability on your CPU, they calculated this 100% CPU here, whatever circle is there, that represents your CPU, ESXi hypervisor CPU resource. Out of this CPU resource, actually finance is allocated 67% of resource. In that, actual usage is 45% only. Whenever it's required, it crosses 45, then whatever free shares are here, that will be consumed here. But I predefined 67% resource to my finance pool from my root resource. However, my finance pool VMs can utilize 45% as per the requirement. Whenever it crosses 45% CPU resource utilization, then it will use whatever free is there out of total capacity 67, out of how much is free is available, that can be utilized when I cross 45% of CPU resource. Even the same scenario for here also. For engineering, you have 33% of CPU resources, shares are there. In that, I can able to use only 22% as per the requirement. When my powered on virtual machine and when I am opened applications, when I am utilizing multiple application, I can able to utilize using only 22% out of 33% of total available CPU resources. Whenever it's needed more, it can utilize this portion, 11% portion, which is available already for your engineering CPU shares. Is that clear or any questions? Okay. So I'm moving to the next slide. So in this slide we are going to discuss about the expandable reservation. So borrowing resource occurs recursively from the incenters of the current resource pool. The expandable reservation option must be enabled. This option offers more flexibility but less protection. So expandable reservation option When you enable it, it is having less protection. Why? Because if you go back to your CPU shares here, so here if you enable the CPU expandable reservation and here also you enable the expandable reservation, so both pools when reaches the crosses the 67% on your finance and crosses the 33% of your engineering pools, this host should have sufficient resource available while creating expandable reservation policy while enabling. If there is no sufficient resource, these pools won't function properly. And if it is not meet the maximum CPU or limit CPU share, that will not allocate or delegate the resource to your particular VMs under your resource pools. Okay, so that is the reason here they said less protection when you enable the expandable reservation on your resource pools. So during enabling the expandable reservation, you have to pre-validate the sufficient resource is available on your root or child resource pools to expand resource. Okay, so in this slide we have root resource pool and retail resource pool and two e-commerce apps pools. One is e-commerce apps and the other is web pool. Overall, we are able to see that root resource pool and child resource pools and sibling resource pool. We are able to see. So in this model, how a mismanaged or missized expandable reservation must or might claim all unreserved capacity from your root resource pool. So have you guys done any sizing on your environment? What does it mean by size? Fine. Sizing in the sense, whatever infrastructure is there in our data center, CPU, memory, disk, network, okay, these should be used in a proper manner. One second. Sorry. Yes, Shidri, you were saying something? So we are discussing about sizing. Every hardware vendor or software vendor will provide their best practices in the sizing tools or sizing sheets. While buying softwares, they will provide that. So we need to use that particular sizing sheets or sizing tools to align or to delegate appropriate resource to your physical hardware components. Okay, the same sizing concept we are using the resource management in VMware. Okay, so using the under the resource management, we'll use various tools like resource pools and various methods like reservations, limit, and shares. Using these methods, we can able to provide the appropriate, provide or delegate or hierarchical manner. We can deploy the VMware virtual infrastructures to utilize resource properly. Okay. So coming to this diagram, we are having a root resource pool, sibling resource pool, and child resource pools. These three components are there. So in root resource pool, we have 10,000. Total CPUs are 10,200 megahertz. Total memory is 3 GB. So this acquired from your, you can say, individual ESXi host or a DRS enabled cluster resource. And using that, we are creating a sibling pool. We have created reservation 300 megahertz out of 10,200 megahertz. We created reservation 300 megahertz, and we enabled expandable reservation. Okay, so the below resource pools can expanded more than 3000 megahertz, then it can utilize the available CPU resource from your root resource pool. In this scenario, your expandable reservation functions properly. Okay. Whereas if you go to the child resource pools, reservation we created 1200 megahertz and expandable is yes. Even here also, the reservation we created 1000 megahertz, expandable no. So let's go to this one. Expandable yes. So in this scenario, reservation for this particular pool I created 12,000 megahertz. So maximum I can able to utilize 12,000 megahertz. Even though if it is crossed 1200 megahertz, I can able to expand my resource pool capacity to my sibling pool. Here I can able to access or expand 800 megahertz for this particular pool. Why? Because in another child pool I already reserved 1000 megahertz and it is not expandable. So this pool can access maximum 1000 megahertz for this particular pool from this sibling pool. And coming to here, your apps pool can access 1200 megahertz. I reserved that. If it is reaches or crosses, I can able to expand maximum 800 megahertz out of this total available capacity. Any questions? Seven, Hari, are you guys are able to follow me? So overall, there should be sufficient resource should be provide for your root, sibling and child resource pools. Then only you can able to size, then only you can able to perform the proper sizing for your hardware resource. Okay, so I'm moving to the next slide. So expandable reservations. So here we have e-commerce resource pool reserve 2200 megahertz of the 3000 megahertz. The same scenario whatever earlier slide we discussed. Here we are discussing same scenario. You have root resource pool and here we are having sibling pool and we are having two more child resource pools. One of the child pool having two VMs and it is reserved with the 400 megahertz and 300 megahertz on one VM. So this two pool total capacity is 1000 megahertz and it is not expandable. Okay. It means you can able to maximum allocate 700 megahertz. Out of these, here if you wanted to expand, if you wanted to provision a new VM with 500 megahertz reservation, it is not possible. Why? Because you are having only 300 megahertz free space is available on this particular pool. When you wanted to deploy a 500 megahertz third virtual machine, your reservation resource pool expandable reservation resource should be in enabled state. Then only you can able to create another VM with 500 megahertz. In this scenario, if expandable resource memory, expandable resource option is disabled, you cannot create it. This is the one of the disadvantage when you disable the expandable reservation on your child pool. So in that scenario, you have two options. Either you have to enable the expandable or you have to decrease the reservation on your virtual machines. Then you can able to provision a new virtual machine with 500 megahertz. Any questions? Okay. Going to the next slide. So even here also we have the same another example. So enable expandable reservation on the e-commerce web pool. The system considers that resource available in the child resource pool and its direct parent resource pool. The virtual machine reservation is charged against the reservation for your e-commerce web. E-commerce web reservation is charged against the reservation of retail. So only here we are describing about your sibling and child resource pool utilization, how it will consume or how it will be hierarched. So end of the day, whatever resource pool you create, root, parent, sibling or child, whatever resource pool you created, those resource pool need to provision the CPU memory resource to your virtual machines. So remember that. Any questions on this slide? So I'm moving to the next slide. So the same scenario explained in the other pool also. Okay. So any questions? So admission control of CPU and memory reservations. So admission control is used to ensure that you cannot allocate resources that are not available. So whatever maximum resource is available on your root resource, that you can able to allocate it. CPU and memory resources are. Apart that, if you wanted to add it, it won't accept. So it maximum your total available resource is 7,770. If you wanted to add more, it will not allow. But in this scenario, there is some calculation wrong here. Okay. Here it shows 13 gigahertz. And when we created that resource is showing only 7,700. So this can maximum we can allocate 13 gigahertz. Let's try this. Something wrong on this configuration. Okay. It's not showing even warning also. So might be it is this infrastructure is deployed on some mission. Looks like that workstation or the base mission having more CPU. That is the reason it's consuming from there. I think yeah, it is nested virtual environment. That is the reason it is consuming whatever available is there. That is consuming from there. Okay, fine. So here in this scenario, so your administration control of your CPU and memory reservations are when power on virtual machine or creating a resource pool with its own reservation or increasing resource pools reservations. These three things can able to perform and succeeded based on your virtual machine condition. Okay, when resource pool expandable reservation is yes, and it goes to the resource when virtual machine power on, then if the sufficient reservation resource is not available, then it goes to your parent pool. Okay, and creating sub pool with its own reservation. Can this pool, new pool or existing pool can satisfy based on allocation of your resource pool capacity? It can be succeeded. So any questions on this slide? I'm moving to the next slide. So resource pool summary tab. So selecting the resource pool tab, you can able to see the resource pool summary tab. Under that, you can able to find CPU resource settings, resource consumers, which VMs are utilizing, which are powered on virtual machines, and child resource pools, and the total resource pool CPU and memory total resource pool capacity. You can able to see it from your summary tab. This is through vSphere web client. Even you can access the same resource pools from your vSphere client also. Okay. Any questions? Okay. Moving to the next slide. Resource reservation tab. So you can able to see resource reservation option from your resource reservation tab on your resource pool. Under monitoring, under resource pool, you can find the monitoring tab. Under monitoring tab, you can find the resource reservation. Under that, you can able to find out CPU, memory, and storage reservations, user reservation, configured reservation, and available reservation, and the expandable feature. If it is enabled, then here it will show you expandable. If it is disabled, it won't show anything, reservation type. Okay. Under that, whatever virtual machine is configured reservation, those missions information also you can able to find out. In this diagram, so reservations are not configured and the limit is configured unlimited. Unlimited in the sense maximum resource whatever is available on your resource pool. Any questions? Okay, moving to the next slide. So scheduling changes to resource settings. So you are having a option or feature. You can able to schedule the resource utilization using schedule task on your vSphere client and your vSphere web client or vSphere client. So using this, you can able to schedule you can able to change your resource pool or VM resource settings. So it will ask you for which resource pool need to be changed, which virtual machine CPU settings need to be changed, it will ask you. So you have to provide that and you have to provide the schedule like whatever here we are seeing. Then that particular schedule time, whatever schedule you've done, that particular time the resource will be changed to your virtual machine. It might be increased, it might be decreased based on your resource pool, resource availability. This schedule changes on to resource settings can be utilized when you are utilizing backup softwares or patching. During that time your virtual machines needed more resource. That time you can choose these scheduling changes on your resource settings on your resource pools or virtual machines. Any questions? in certain time I need some specific resource, that time you can use the schedule changes, then you can modify the settings. Any questions? Okay. Shall I move to next slide? So managing resource pools, lab, you have to do it. If you do multiple times, then only you can able to understand this resource pools management concept. Okay. If you are good with these concepts, you can able to easily manage your infrastructure resource. You can able to guide or you can able to size it appropriately. Okay. So this is the list here. These all are available on your lab tasks. So monitoring resource usage. Shall we continue today? Okay. So are you guys are available on evening? 1 hour. Let me know the time frame in the evening between 7 to 9, or we can discuss same time tomorrow morning. It's up to you guys. Just ping me, are you guys are available evening or can we discuss tomorrow morning? Okay. Chalo. Thank you all. Bye.